In Chapter 7, Section 1, we're going to be looking at chemical formulas. So we are going to be learning what a chemical formula is and what information we can get from a chemical formula. We are going to learn how to write the formula of both ionic and molecular compounds when given their formula. And we are going to learn how to write the formula for both ionic and molecular compounds when given the name. So a chemical formula basically tells you two things. It'll tell you what elements are in your compound, and it'll also tell you the relative amounts of those elements. So the first example we're going to look at here is for a molecule of water. So I am going to build a water molecule real quick. So now if we take a look at our water molecule, we can see that this molecule consists of one oxygen atom bonded with two hydrogen atoms. So the red is the oxygen, the yellow it would be the hydrogens. And since it's combined in a ratio of two hydrogens and one oxygen, we're going to write the formula as H2O. And that little subscript 2 by the H tells you that there are two hydrogens for every one oxygen. Next, we're going to look at binary ionic compounds. Binary means combined of only two types of atoms, and ionic means that these are composed of ions, which are charged atoms held together by electrostatic forces. And the binary ionic compound that we're going to make here is hydrogen fluoride. This compound consists of a hydrogen ion ionically bonded to a fluoride ion. Now the hydrogen ion has a positive 1 charge, and the fluoride ion has a negative 1 charge. When you put together ionic compounds, it's very important that your charges or your oxidation numbers add up to 0. So in this case, a +1 and a -1 together make 0. So you would combine these in a 1-to-1 ratio. So the formula is just going to be HF. Now we're going to look at a slightly more complicated example. This is going to be another binary ionic compound. This is going to be copper chloride, specifically copper 2 chloride. Now when you see the names of elements or ions with a Roman numeral following the name, like copper Roman numeral 2, this is the stock system of nomenclature. That Roman numeral number 2 tells you that your copper has a positive 2 charge. Now they have to do this because different ions of copper can have a different charge. You can have copper 1 with a positive 1 charge or copper 2 with a positive 2 charge. And we need to be able to tell the difference between those two. So that, again, that's why we use a Roman numeral in the stock system. So here we have our copper with its positive 2 charge, and this is going to be copper 2 chloride. So now we're going to combine it with a chlorine. And our chlorine has a -1 charge. So looking at this right now, we've got a positive 2 charge and a -1 charge. Now that does not add up to 0. So we are not done with this yet. How we're going to get this to equal 0 is we're going to go ahead and add another chlorine on there, another chloride I should say. And adding another chloride is going to give us another negative. So now you can see we have our positive 2 from our copper, and we have two -1s from the two chlorides, so our formula is going to be CuCl2, and that little 2 needs to be a subscript 2. Now we're going to try a molecular compound. The molecular compound we're going to do is carbon dioxide, and molecular compounds work a little bit differently. Molecular compounds get named with a set of prefixes to indicate how many of each atom you have. So this carbon dioxide has one carbon and two oxygens. So we indicate that there are two oxygens by using the prefix di. So carbon dioxide. And again, to indicate that there are two of the oxygens in the formula, we're going to use that subscript 2. Now we are also going to have to know the name of some common acids. Now these don't follow the same rules as everything else that we have just learned about. Unfortunately, these are things that we're going to have to memorize. So if you look on page 230 of your book, down at the bottom, there's a table called Table 5. We're going to make some flashcards, and we are going to work on memorizing the names and formulas of these common acids.